Alright, so what we are going to talk about today is, I know we've mentioned in previous lectures about this plus c that always has to follow the antiderivative. Well, now what we're going to do is we're going to talk about what happens when we have some information that helps us figure out what that constant c is. So this process is called integration, and it's very, very closely related to antidifferentiation. So I may use words like integral, integrate, antidifferentiate, antiderivative interchangeably because they are so closely related. So let's talk about what integration is, and I think we start off with an example on this one. Maybe. Here we go. So if I am given that f prime of x is 4x, and I know that f of 1, notice there's no derivative here, so I'm actually talking about the original function that I'm hoping to find. F of 1 is 7. Now I need to find what f of x actually is. So I know that f prime of x is 4x. So I have to antidifferentiate that, or take the antiderivative of that. Okay, so that's when I use that funky symbol, funky s symbol, and the dx. And if I actually find the antiderivative of that, then that is 2x squared plus c. And I always remember that plus c. Well, now I know that f of 1 is 7. So what I can do is I can plug in 1 everywhere there's an x. So f of 1 would then be 2 times 1 squared plus c, and that would equal 7. So now if I just look at everything over here, I've got enough information to figure out what my value of c is, what my constant is. So 2 plus c is 7, well then obviously c is 5. And so now I can go back up to where I originally started talking about f of x, and I actually had a function here, and I can replace that c with the number 5. So I can confidently say that f of x is 2x squared plus 5. Okay, so this is just using something that I know about the function to figure out what c is and to completely write out what the function should be. Alright, and moving on. So now, if I could ask you questions about the first derivative, I could certainly ask you questions about the second derivative. So given that f double prime, or the second derivative of f, is 12x, and given that the first derivative is equal to 5 when x is 1, and given that the function is equal to 6 when x is 1, we need to find f of x. So this is a completely valid question that I could ask. I'm basically going to have to go through the process twice. Okay, so let's start. If the second derivative is 12x, then I know that the first derivative is 6x squared plus some constant. And I'm going to call that constant c1. The reason is because I'm going through this process twice. So that means I'm going to have that plus c twice. Well, I can't call it c both times, so I'm going to call it c1 the first time and then c2 the second time. Alright, so just like before, I found a general solution for what f prime is, but I also know that when x is 1, the first derivative is 5. So I plug in x equals 1, and I figure out very quickly that my first constant, my c1, is negative 1. So that allows me to more accurately say what f prime of x is. So I now know that f prime of x is 6x squared minus 1. Now I can go on to the next step, which is figuring out f of x, and I do the same process again. So I know that the antiderivative of 6x squared minus 1 is 2x cubed minus x plus another constant. And now I go back to any information I have about f of x, and I know that f of 1 is 6, so I plug in 1 everywhere there's an x, and I set that whole thing equal to 6. So 2 minus 1 plus my constant is equal to 6. And that means that my second constant is equal to 5, meaning that I now know that f of x is 2x squared minus x plus 5. And if I wanted to check to make sure that my answer was correct, I could very easily take the derivative of this to get 6x squared minus 1, and then I could take the derivative of this to get to 12x again. Alright, so that's kind of how you do those. Another question I could ask is if I asked you to integrate something like this. And I want you to be careful because there are things that you may think you can do, but they're not necessarily things you can do. Looking at this, you might be tempted to just take the antiderivative of 2x plus 5 and square that. Well, there's no rule that says you can do that, and in fact, there are rules that say you can't do that. So I have to find some other way of writing 2x plus 5 squared, and unfortunately the only way I can think of is to actually square it out and get 4x squared plus 20x plus 25. There is a property that says I can anti-differentiate each one of these separately and add those together. So that was one of the properties we talked about in an earlier video. So the antiderivative of 4x squared is 4 times x cubed over 3. The antiderivative of 20x is 20 times x squared over 2, and the antiderivative of 25 is 25x, and I'm not forgetting my plus c. All right, and if I simplify that a little bit, just making the fractions look a little nicer, that gives me 4/3 x cubed plus 10x squared plus 25x plus c. And I didn't go as far as to give you some initial conditions because we had already done that, but be prepared, you might get some information about f of x that allows you to figure out what this constant is. All right, and our last example is this one right here. So I need to know how to handle things like this too. And you may be tempted to find the antiderivative of the top and divide it by the antiderivative of the bottom. But again, there is no rule that says you can do that, and in fact, there are rules that say you can't. If I was asked to find the derivative of this function instead, I couldn't just take the derivative of the top and divide by the derivative of the bottom. I would have to use the product rule. So if I can't do it in derivatives, then I obviously can't do it in antiderivatives. But I have to do something. So what I do is I actually divide each of those terms by the square root of x. And when I do that, I get x to the 3/2 minus 2x to the 1/2 plus 3x to the negative 1/2. And then I have to take the antiderivative from there. Okay, so the antiderivative of x to the 3/2 is x to the 5/2 over 5/2. Whoops, just lost it. The antiderivative of 2x to the 1/2 is 2x to the 3/2 over 3/2. And the antiderivative of 3x to the negative 1/2 is 3x to the positive 1/2 over positive 1/2. And then I need to clean those up a little bit because what I've got is fractions within fractions. So instead of dividing by 5/2, I'm going to multiply by 2/5. 2 divided by 3/2 is the same thing as 2 times 2/3. And then 3 divided by 1/2 is the same thing as 3 times 2. So I end up with 2/5 x to the 5/2 minus 4/3 x to the 3/2 plus 6x to the 1/2 plus c. And again, I didn't give you any initial conditions that allow you to figure out c because we've already done examples of that. So I just, be prepared for earlier examples mixed with examples like this in class tomorrow. These are just very, very basic, and we're going to get more complicated with our examples tomorrow. So if you have any questions, you know how to reach me, and I will see you tomorrow.